Let's take a look at this example. First, we're supposed to find total resistance. So, R total is equal voltage source over I total. This is Ohm's law. Voltage source is equal 80 volts and I total is equal 25 milliamps. Okay, so this is equal 3.2 kiloohms. Okay, this is my R total. Next, I'm going to find R3. I'm going to use the formula called the product over the sum in order to find R3. Of course, you can use different way to find R3, but I want you to practice this method too. But before I'm going to do the algebra, I would like to just redraw the circuit a little bit. So we have voltage source, we have resistor R1, and these two resistors are in series. I'm going to call both of them R2, 3. As you can see, we end up with two resistors which are in parallel. That's why I can use the formula called product over the sum. The formula says R total is equal R1 times R2, 3 over R1 plus R2, 3. Next, what we're supposed to do, we have to solve this formula for resistance R2, 3. Okay, in order to do so, I'm going to multiply both sides of the formula by the denominator. So I have R total times R1 plus R2, 3 is equal R1 times R2, 3. Next, I have to distribute R total into the parentheses. So I have R total times R1 plus R total R2, 3 equals R1 times R2, 3. Because I'm looking for R2, 3, I'm supposed to collect all terms which contain R2, 3 on one side. I'm going to move this term to the right side. So if R total R1 is equal R1 R2, 3 minus RT R2, 3. Next, I'm supposed to factorize R2, 3. So R total R1 is equal R2, 3, and I have R1 minus R total. Okay. In order to solve this formula for R2, 3, I have to divide both sides of my formula by whatever is multiplied to R2, 3. So I divide by R1 minus RT, and I have R1 minus RT. And we end up with R2, 3 is equal RT R1 over R1 minus RT. Okay? So, next we're supposed to plug in the values. So we found that R total is equal 3.2 kiloohms times R1, which is equal 12 kiloohms. So I have times R1, 12 kiloohms, everything over R1, 12 kiloohms, minus R total, 3.2 kiloohms. This is equal 4.36 kiloohms. Okay? But please notice, this is point, okay? Please notice that we're not looking for R2, 3. We're looking for R3. As we said before, these two resistors are in series, so you have to realize that R2, 3 is equal R2 plus R3. We found R2 we have given R2, so we can find very easy R3 by solving this formula for R3. So you'll get R3 is equal R2 minus R2, where R2 we found is equal 4.36 coulombs minus R2, which is equal 3 coulombs. This is equal 1.36 coulombs. So this is the value of resistor R3. Next, we are going to find voltage across resistor R1. Please notice that resistor R1 is connected directly to the voltage source. It means that resistor R1 is in parallel with the voltage source. Keep in mind that in parallel circuit the voltages are the same. So you're supposed to realize that V1 is equal voltage source, which is equal 80 volts. Okay, so this is the voltage across resistor R1. Next, we are going to find the current which goes through these two resistors. Okay, we can use KCL, but we can use also Ohm's law. I'm going to use Ohm's law. So V23 we found is equal 80 volts, right? Voltage across these two resistors together is equal 80 volts. So if you want to find the current I23, you're supposed to simply divide V23 by R23. V23 is equal 80 volts, as we said, over R23 4.36 coulombs. This is equal 18.34 milliamps. Okay, so it means that I2 is equal to I3 because these two resistors are in series. Okay, and this is equal I23, which is equal 18.34 milliamps. I call this I23 because this is the current which goes through this resistor, but this resistor represents these two resistors combined together. So we found I2 and we found I3. Next, we can find also I1. I1 is equal voltage across resistor 1 over R1. V1 is equal 80 volts over R1, 12 coulombs. This is equal 6.67 milliamps. Next, we're supposed to find the voltages across resistor R2 and across resistor R3. Okay, we found I1. And V1 we said is also equal to voltage source 80 volts. That's why I'm going to cross this out. So V2, in order to find V2, I'm going to use Ohm's law. So V2 is equal current which goes through resistor R2 times the resistance of resistor R2. So I2 is equal 18.34 milliamps times R2, which is equal 3 coulombs. This is equal 55.02 volts. Okay, so this is the voltage across resistor R2. Next, I'm going to find voltage across resistor R3. So V3 is equal I3 times R3. So I3 is equal to I2, 18.34 milliamps, times R3, which is equal, we found 1.36 kiloohms. Everything is equal 24.94 volts. Okay, so this is my voltage across resistor 3. If you are going to add these two voltages, you're supposed to get the value around 80 volts. Okay, so let's verify. So voltage source, right, or we can say V23 is equal V2 plus V3. So I have 55.02 volts plus 24.94 volts is equal 79.96 volts. As you can see, this value is very close to 80 volts. That's why we can say that our calculations up to this point are okay. So we have V2 and V3. Next we can find the total power. P total is equal I total times voltage source. So I have I total 25 milliamps times voltage source, which is equal 80 volts, is equal 2 watts. Okay, so this is the total power in my circuit. Next, we are going to find the power at resistor R1. Okay, so P1 is equal voltage across resistor R1 raised to the second power over R1. I'm going to use this formula. So I have V1, we said is equal 80 volts, raised to the second power over R1, 12 kiloohms. This is equal 533.33 milliwatts. Okay, so this is the power at my resistor R1. Next, we are going to find the power at resistor R2. Okay, we found P total and P1 so far. So P2 is equal I2 raised to the second power times R2. I2 is equal 18.34 milliamps raised to the second power times R2, which is equal 3 kiloohms. This is equal 1 watt. Next, we're supposed to find power at resistor R3. So I have I3 raised to the second power times R3. So this is equal, I3 we'll calculate is equal 18.34 milliamps raised to the second power times R3. We found R3 and this is equal 1.36 kiloohms. This is equal 457.44 milliwatts. Okay, so this is the power at resistor R3. Next, it's always good to verify if answers are correct. So we can write that P total is the sum of all these powers. So P1 plus P2 plus P3. P1 we found is equal 533.33 milliwatts plus P2 1 watt plus P3 457.44 milliwatts. Everything is equal 1.99 watts. Let me remind you that the total power we found before, okay, the one which we found before was equal 2 watts. So as you can see, this value is very close to 2 watts. So it means that the calculations are correct and the problem is finished.